Can we graph that? This is the gradient. It's up over across. We can do it twice over. We can move the line up or make it perpendicular. Or make it perpendicular. Can we graph that? This is the gradient. It's up over across. We can do it twice over. We can move the line up or make it perpendicular. Or make it perpendicular. That's a bit of Macklemore for you there. I didn't try and do any of his rap because I don't think I could have coped with that. So, okay. Anyway, you might have already gathered, we're moving into linear graphs. Okay, so let's just start off with some definitions. This here is an expression. It's just a little bit of algebra, but with no equal sign of any form. So it's sort of meaningless on its own, just maybe early stage in somebody's working out. This here is an identity. And what that means is that the left-hand side and the right-hand side are identical. They're just two different ways of saying exactly the same thing. So, for instance, if you were to take the left-hand side of this and multiply it out, it will give you a half x minus 2, which matches that. So you can't solve that because there's nothing, you're not going to find any individual value that works. It works whatever x is because both sides are always the same regardless of what value x is. So that's an identity. Identity should contain the 3-line equal sign. Sometimes people are lazy and they don't bother to show it, but ideally they would. This here is an equation. And this is a linear equation, and we know how to solve linear equations because we've done them already a little bit. So if we have a half x minus 2 equals 3, we could solve that. We could think about a flow diagram, x times a half minus 2. So add 2 to both sides to reverse the minus 2. And so it gives you a half x equals 5. And then to get rid of the times a half, you can either divide by half or times by 2. They're the same thing. So I'll times by 2. And so that's going to give me x is 10. So that tells me that this equation here only works when x is 10. That's the only solution for that equation. Over here, we have a quadratic equation. So quadratic equations, generally speaking, they have two solutions. Sometimes they have one solution, but when they do, we'll call it a repeated solution, so still claim it's two solutions. And sometimes they have no solutions at all, but we'll find a sneaky trick for saying that's two solutions as well. Much later on in maths we'll do that. Okay, so how do we solve these quadratic? Generally speaking, we move everything to one side. So add the 7x to both sides. So that's going to be 2x squared plus 7x equals 15. And then now minus the 15 from both sides. And so it's going to be 2x squared plus 7x minus 15 equals 0. So you're trying to make this side equal to 0. And then we're going to try and factorize it. So we're going to say maybe there's a 2x there and an x there. And because there's a minus here, then we'd have to have a plus and a minus. I don't know which way around they go, so I'll just guess them for the time being now. I'll say that that's a minus and that's a plus. And then I need to put in multiples of 15 here. So 5 and 3 I'm going to choose. So 3 here and 5 there. And I'll just try multiplying that out. So that's going to give me 2x squared plus 10x and then minus 3x, which gives me plus 7x. And then minus 15. So that worked out perfectly well. And so either this first factor's got to be 0, in which case x would be 3 over 2. So x is 3 over 2. Or this second factor's going to be 0, in which case x would be minus 5. So x is minus 5. So this quadratic has two solutions. And we will see that more complicated equations like cubics or quintics or trigonometric equations, they might have many more solutions. But equations have certain distinct values for which they work and a whole load of other values for which they don't work. Okay, now we've got the same thing, but we haven't just got x. we've got y in there as well. So this is an expression with x and y in it. This is an identity with x and y in it. And last of all, we have here an equation with x and y in it. So this is an equation. Now we can't solve this like we could solve the other one because there's not one unknown. X is an unknown variable and y is an unknown variable. So what we could do instead is we could try and plot it. So the way we would plot it is we just try some different values of x. You can try x is 0, 1, 2. I'll skip a couple. I'll go to 4 and I'll skip a couple more and I'll go to 9. You can just put them all individually if you want, doesn't matter. If I put in x is 0 into there, a half of 0 is 0 minus 2. It's going to give me y is minus 2. So this is the coordinates of a point 0, minus 2. 0 along x and minus 2 along y. So I'll just place a little dot and then I'll carry on. If I put in x is 1 into there, I get a half times 1 is a half, minus 2 is minus 3 over 2. And so that gives me the point 1 and minus 3 over 2, minus 1.5 there. And then I'll put in 2 into the equation. So if I put in 2 into that equation, a half of 2 is 1, minus 2 is minus 1. So another point would be 2, minus 1. So 2, and I'm going to skip to the next point, which I skipped a couple and went to 4. A half of 4 would be 2, minus 2 would be 0. And so that will give me the point with x coordinate 4 and y coordinate 0. So x coordinate 4 and y coordinate 0. And then I've got a final point there as well, which I can just do 9. So a half of 9 is 4.5, minus 2 is 2.5. I'll call it 5 over 2. So when x is 9, y is 2.5. When x is 9, y is 1, 2, 2.5. Now what you'll find is all those points lie along a straight line. So there's a straight line that I can draw that goes through all of those points. Y equals a half x minus 2. And I've found 1, 2, 3, 4, 5 points on that line, but there are infinite points along that line, and the line stretches to the left in this direction and to the right forever, to the left forever and to the right forever. So when you have something like this, it represents the equation of a line, and you can draw that line. And I overdid it. I did way too many points to draw that line. You only really need 2 points to draw the line. Once you've got the 2 points, you can just connect them back together, connect them together again. So for instance, if I were to, let's just say, let's move that out of the way. If I were to get rid of that, and get rid of that, and get rid of that, and just have the 2 points that I started with, I would still get the same line going through those 2 points. It'd be exactly the same line. So let's come up with some terms that we use when we're talking about a straight line. We talk about the gradient of the line. And the gradient of the line is if you pick 2 points on the line, you can pick any 2 points you like on the line. Generally speaking, you're looking for integer points. So you might choose this point and this point. You might choose those as your 2 points on the line. Because this is the point 0, 0 and this is the point 1, 1. Okay? And what you're going to do is see how much do you have to go up and how much do you have to go across to get from the point on the left to the point on the right. So how much do I have to go up? I have to go up 1. And how much do I have to go across? I have to go across 1. So I've just shown that up 1, across 1. Oops, that's gone slightly wrong. Let's just redo that. So across is 1 would be like that. And up is 1 would be like that. Okay, and we're going up to this point here. Okay. And so my gradient is up over across. You can see I'm going up 1 and across 1. So my gradient is up over across, which is 1 over 1. This line has a gradient of 1. The grid that I've drawn has equal aspect. That means if you measure from 0 to 1 on the x-axis and you measure from 0 to 1 on the y-axis, it's exactly the same. So in this case, I've put a grid with equal aspect. It won't always be the case that there'll be of equal aspect. When you have a grid of equal aspect, a line of gradient 1 will be at 45 degrees to the x-axis. So this angle here is 45 degrees. 45 degrees to the x-axis. What is the gradient of this line here? So again, we're going to do the same thing. We're going to pick some integer points. So we're going to pick the origin. Now that's not going through a whole number. Well, it is sort of going through a whole number, but I'm going to choose this point here because that's 1 and 2. This is a whole number on the y-axis, but it's a half a number, but it's an exact half. You could have chosen that point, it will work fine. And so my gradient is the same thing. How much do I go up? 2. And how much do I go across? 1. So my gradient is 2. So this line has a gradient of 2. And you can see that it's a steeper line than the one I had previously. I've got another question here, which is what is the angle of this line? And I've got a way of measuring it on here, which is, I've got a little protractor here. If I just move my protractor to here, like about 63, maybe 64 degrees. 63 or 64 degrees, that line. I'll just get rid of the protractor now. So I think it's about 63 or 64 degrees. I don't know, I can't tell, so I'm just going to call it 63.5 degrees. So I'm going to say it's 63.5 degrees. You can't measure it that accurately with a protractor. But there's a clever trick we can use to work out the angle. If we know the gradient, and we do, we said the gradient was 2, what we can do is we can pick up our calculator and do inverse tan, so shift and tan of the gradient. The gradient was 2. Inverse tan of 2, and it tells me it's 63.43 degrees. So it's able to give me a much more accurate answer, 63.43 degrees. Okay, that's just to 2 decimal places. I could have it more accurate than that if I wanted it. What about this line? What's the gradient of it? Well, I'm having to search quite hard to find some integer points here. I can't see any integer points. Ah, here we go. There's an integer point. So that's the point that I'm going to use. And so my gradient is going to be from here to here. I have to go up 2.5 and across 3.5. So my gradient is going to be up, which is 2.5, over across, which is 3.5. I mean, I can rewrite that as being 5 over 2 is 2.5 over 7 over 2. And then those will cancel out and gives me 5 over 7. So my gradient is 5 over 7 for that line. So that's the gradient for that line. Sometimes you'll get lines, I mean, it won't be at this stage, but sometimes later on in maths we'll get lines where there aren't any integer points on those lines. It never crosses through any integer points, in which case the best we can do is approximate the gradient. We can't get it accurately in that case. Okay, this looks identical to the last one. The line is sort of identical, but it's got a warning here, which is saying this grid has an unequal aspect. So the gap here from 0 to 1, the gap from 0 to 1 on the y-axis would, well, 1 would just be here on the y-axis. So that's the gap from 0 to 1 on the y-axis, and that's the gap from 0 to 1 on the x-axis. So this has been squished. The y-axis has been squished to fit more of it in. And so this has an unequal aspect. That means when we're measuring angles using a protractor, we won't get the right result because somebody's squashed it. And if they've squashed it, then we'd need to unsquash it to get the right angle for that line. Anyway, it doesn't matter. We can still find the gradient in the normal way. I'm just going to pick some nice integer coordinates. So that's not an integer. There's my integer coordinates. From here to here, how much do I have to go up? That's up is 10. And then how much do I have to go across? Across on this grid would be 4. Across is 4. So my gradient is up over across 10 over 4, which will cancel down to being 5 over, oh, it's not 4, it's 3.5. My mistake. It's not 4, it's 3.5. So it's 10 over, that should be 3.5. 10 over 7 over 2, which is 20 over 7, is the gradient of that line. So it's actually a steeper line than the previous one. It just doesn't look at it. This has got a gradient of almost 3, whereas this one had a gradient of less than 1. But they look identical. Watch out for those unequal aspects. What's the gradient of this one? Well, we can see to get from here to here, you go up -1. You don't actually go up, you go down 1. And then you go across 2. So the gradient of this line is up over across is -1 over 2 is the gradient of that line. Okay, it's got a negative gradient. What I mean by that is it's downhill. If you were on a car driving down this road, you'd be going downhill. So negative gradient means downhill. Oh, this is a steeper negative gradient. I'm sure you can tell me straight away what the gradient of that is. I'm sure you can tell me immediately what the gradient of that is. It's an equal aspect. The gradient is up over across, which is -1 over 1, which is -1. And a -1 gradient will be 45 degrees below the x-axis. So when we're measuring angles, we measure them. There's another topic in maths we'll do later on called bearings. And in bearings, it's not really maths for mathematicians. It's maths for pilots and ship's captains and stuff like that. In that case, we'll use a north, and we'll use angles being measured clockwise from the north. But other than that, we measure angles anti-clockwise from the positive x-axis. So parallel and perpendicular gradients. If I want to create a line that's parallel to this one, what I can just do is there. I've created a line that's parallel to this one. Now if I look at the original line, you can tell me what its gradient is. Yep, the gradient is -1/2. This gradient is going to be the same. You're going to go -1 up and 2 across. So the gradient is going to, so parallel lines have the same gradient. The gradient here is going to be -1/2. If you see two lines and they're parallel, then they have the same gradient. What about a perpendicular line? Perpendicular means 90 degrees. So we want a line that's at 90 degrees to this one. So how do I get a line that's at 90 degrees? I'm going to call back into service that protractor, and I'm going to move it to there, and then I'm going to rotate it, and that tells me that my 90 degree line would have to go like that along that 90. Oh, I missed it. That's not far off. Okay, so this here is my perpendicular line. It's at 90 degrees. So we use the word perpendicular to mean 90 degrees. We also use the word normal to be 90 degrees. So this is a perpendicular line. Perpendicular. You can call it a perp for short. Although Americans will get confused because they call that a perpetrator, as in somebody who's committed a crime. Okay, how do we find the gradient of this perpendicular line? Well, what I'm going to do is take my gradient of my previous line here, and I'm just going to slide it there and then rotate it around until it lines up with my perpendicular line. Okay, there we go. I think that's roughly it. Okay, and what I can see is, well, I can see now that my line missed a little bit. Let's just move my line slightly to get it a bit more correct. Okay, that's a more correct version of it. And now I can easily find the gradient. How much do you have to go up? You have to go up 2, and how much you have to go across? 1. So the gradient of this is 2 over 1. And remember, the gradient of this was -1/2. And so what happened was the bit that used to be up, well, it was actually down, became a bit that's across, and the bit that used to be across became the bit that's gone up. So what you notice is the fraction has flipped, but you also notice another thing, the sign has changed. Okay, so that's a perpendicular gradient. This is your question 1. So the grid will be linked in the description below. And it says, do the gradient triangle like we did before to evaluate the gradients of these two lines. And I've given you a couple of good points to use for your gradient triangles. And then it says, now add perpendiculars to each line. So break out your protractor and add a perpendicular to each of the lines. And then use the rule theta equals tan to -1 gradient to find the angle that each line makes with the positive x-axis. So I'm interested in this angle here. And I won't call it theta, I'll call it alpha. And I'm interested in this angle here. and I'll call it beta because I can't call them both theta, so I switched to using theta is from the Greek alphabet. That letter there is theta, it's from the Greek alphabet, and so are alpha and beta from the Greek alphabet. So that's alpha, and that's beta. Okay, so that's your question 1. The root and the y-intercept. So whenever you have a line, it will, not always, but pretty much always, at some point it will cross the x-axis. So that we would call the root or the x-intercept. And where it crosses the y-axis, that we would call it the y-intercept. So the root and the y-intercept are the points where it crosses the x-axis and the y-axis. Y-intercept is quite obvious, isn't it? That's quite self-explanatory. Intercepts the y-axis. And root is, I don't know, I suppose you could imagine that this is like the ground. And this is a plant, I don't know why it's growing up at an angle. And then over here, underneath the ground is where the roots are. So the roots are here underneath the ground. So the root is where it hits the ground. I don't know, maybe that's a way of understanding the word root. Okay, now we want to be able to draw straight lines on a grid. So the first line they've given us is the line y equals 5. And it says horizontal lines are always of the form y equals and then just a number. So this must be a horizontal line at 5. So it must be a horizontal line and it must be here at 5. Oh, I didn't want an arrow on it. I've accidentally got an arrow on it. Anyway, it's that horizontal line there. And the reason is, if you pick any point on this line, its y coordinate will always be 5. So if you pick this point here, it's got an x coordinate of -4 and a y coordinate of 5. Or if you pick this point here, it's got an x coordinate of 6 and a y coordinate of 5. So that's the line y equals 5. Every point on that line has a y coordinate of 5. And more interestingly, where it cuts through the y-axis will be at 5. X equals -3. X equals -3 will be that line there. Those are the points which all have an x coordinate of -3. And most usefully, that line crosses the x-axis at -3. So they're easy, they're pretty straightforward. Okay, sometimes they give you the equation in this form, y equals mx plus c. Y equals mx plus c is called the gradient-intercept form for a straight line. The number next to the x is the gradient, and the number that doesn't have an x next to it is the y-intercept. So they're asking us to sketch this line, and you can see it's in that form, and I can tell you that the gradient is 2 and the y-intercept is -3 just by using the rule. The number next to the x is the gradient and the number on its own is the y-intercept. So how do I sketch it? Identify the y-intercept. Well, I did that a second ago. The y-intercept is this. It's the -3 is the y-intercept. And place a blob on the y-axis at -3. Okay, so just put a little blob there at -3 on the y-axis. Okay, done that. What's it want me to do next? Write the gradient as a fraction. Well, I know that this is the gradient here, and it wants me to write it as a fraction. Well, it's not a fraction, it's an integer. How do I write that as a fraction? We'll write it as 2/1. That would be the same as 2, and it's a fraction now. Write the gradient as a fraction, and then add these suffixes. Up and across. So on the top you add up, and on the bottom you add across. So change that fraction, change that 2, that gradient, into a fraction 2 up over 1 across. Now, starting from the blob you put on earlier on, do as the gradient says. The gradient says to go 2 up and then 1 across, and then place another blob. Okay, so they want me to start from here and then go 2 up, 1 across, and then place another blob. So here's another blob. Start from here, go 1, 2 up, 1 across, and then place a blob. Okay, done that. And then it says, now connect the blobs with a straight line. Okay, I don't know if I'm going to get it to hit. No, I missed by quite a way. There's my straight line. It's my best attempt at it. And so to connect that with the straight line, and now we've drawn the line, y equals 2x minus 3. The only thing left to do is to label the line. This line is y equals 2x minus 3. Let's label it. Y equals 2x minus 3. And we can rotate that label to the same angle as the line and put it alongside the line. There we go. So we've labelled that line, we've drawn that line there. So here's another one. It's asking us to sketch the line y equals 5 minus 2/3 x. So which is the y-intercept? It's the one that doesn't have an x next to it. Yep, the y-intercept is 5. So I'm just going to put a blob at 5. Now write the gradient as a fraction. So the gradient is this number here, minus 2 up, 3 across. Minus 2 up, 3 across. So starting from my first blob, I'm going to go minus 2 up and then 3 across. So starting from this blob, minus 1, minus 2, 1, 2, 3 across. And then connect those blobs together with a lovely straight line. Hopefully hitting all the blobs. No, okay, fine, never mind. Label the line. Y equals 5 minus 2/3 x. Bring it onto here. Okay, so that was easy to draw. Okay, now it's got a different form for the equation of a line. So it's like this now. X over b plus y over c equals 1. That's got to be a 1 at the end there. And that's called the two-intercept form. So how do I sketch this? X over 4 plus y over 8 equals 1. And it tells me some information. The number under the x is the root. The number under the y is the y-intercept. So what's it want me to do? Identify the root. Well, that's the number underneath the x, 4. So I'm just going to place a blob at 4 on the x-axis. At 4 on the x-axis. That's the root where it hits the x-axis. So I've put a blob there. And that's called the root or the x-intercept. And this is why it's called the two-intercept form. What's it say to do next? Identify the y-intercept and place a blob on the y-axis. Well, this is the y-intercept, the number underneath the y. So I'm going to place a blob at 8 on the y-axis. So these are my two blobs now, the blob at 8 and the blob at 4. And then connect them with a straight line, of course, like we always do. Line, it's going to be, so there's my straight line. Label the line. X over 4 plus y over 8 equals 1. Move the label onto the line. And so there's that line drawn. So that's in two-intercept form. Okay, what have they done here? They've done a few things weirdly. They haven't made that 1, they've made that 3. Luckily they highlighted it for me, otherwise I might not have noticed. And they haven't got a plus here. They've got a minus here. Okay, is the root still going to be 5? No, it's not. It's actually going to be 15 because you've got to multiply the 5 by the 3. Because they haven't made that a 1, you have to multiply it by this number here, 3. So the root is going to be at 15. So the root is going to be at 15. What about the y-intercept? Now we got the same issue here. We're going to do 2 times 3 is going to give me 6. But also that minus, really you can move that minus down to here. You can change that into a plus and instead put the minus here. That would be the same thing. You've just moved the minus down to there. And so you can see you're multiplying the 3 by minus 2. So that's going to give you minus 6 for the y-intercept. So minus 6 is the y-intercept is there. And then connect those together with a straight line. Straight line. Okay, that's looking pretty good. And then just label it. X over 5 minus y over 2 equals 3. And then just move it. Okay. The last way that they might write the equation of a line is called the standard form or the coefficients form. That's, a number in front of the x plus a number in front of the y equals a number. And these are usually all integers. So that would be the standard form. They'd all be integers if possible. How do we sketch this line? So it does tell us the root is c over a, so this number divided by this number, and the y-intercept is c over b. Let's see why that's the case. So the first thing it says is to identify the root. And the way we're going to do that is we're going to make y equals 0. And the way to make y equal 0 is to just scrub it out. Just scrub it out. And what you get when you scrub that out is you get 2x equals 15. And you can solve that to get x is 7.5. So we can put a root at 7.5. Now identify the y-intercept. Okay, so we're going to do the same thing again. We're going to scrub out. We're going to make x equal to 0. And if you make x equal to 0, you're just going to get 2 times 0. You can scrub that out. And that's going to give you 5y equals 15, which we can solve to get y equals 3. And so we put a blob at y equals 3. Connect the blobs together with a straight line and label your line. Okay, and then label the line 2x plus 5y equals 15. So this is again the standard form. So if I want to find the root, what I'm going to do is make y equal to 0. So this rule about finding the root, make y equal 0, is going to always apply in all types of equations. We're just doing linear equations, but when we move on to more complicated equations, it's going to work as well. So if I make the y equal to 0, that's going to scrub that out. And then we're going to get 3x equals 24, which tells you that x is 8. So I know that the root is that x is 8. I'm going to make x 0. So to find the y-intercept, you make x 0. And that's going to give me minus 8y is 24, which I can easily solve by dividing by minus 8. And that gives me y is minus 3. So the y-intercept is at minus 3. 3x minus 8y equals 24. Okay, so this is your question 2. And again, the grid will be linked, grid 2. And it's asking you to draw these 3 lines. So this line is obviously in gradient and intercept form. This line is sort of in the two-intercept form, but that's a minus 1. So the root isn't going to be at 4, it's going to be at, and the y-intercept isn't going to be at 6, it's going to be at, and then this is the standard form. There's a trick to finding the angle that any line makes with the positive x-axis. Just do inverse tan the gradient, we know that. Calculate the angle this line makes with the positive x-axis and confirm it using a protractor. The points A, B and C where the lines meet, labelled clockwise from the top, form a triangle. Give the coordinates of A, B and C. Well, C you're not going to be able to give its coordinates exactly because it doesn't meet at, integer point. It meets a bit in the middle. And then it says measure all 3 angles in this triangle, giving each angle to the nearest whole number. It's just asked you to, this is just measuring them, you don't need to calculate. Okay, so now we're going to move on to finding the equation of a line. So before we were drawing the line, now we're trying to figure out what the equation is somebody else has drawn it. And there are 3 situations. We might have a horizontal or vertical line. We might have a line where they make it easy for us to see the gradient and the y-intercept. Or we might have a line where the root and the y-intercept are obvious. So we just deal with them one at a time. So this is a vertical line. Vertical lines are all of the form x equals a. Where does it cross the x-axis? At 9. So this line is just x equals 9. That's that line. X is 9. This is a horizontal line. They're always of the form y equals c. Where does it cross? It crosses at minus 2. So the equation of the line is just y equals minus 2. They're easy horizontal and vertical lines. Okay, on this line, I can see that the y-intercept is minus 3. And they've really nicely mapped out the next whole number point that it crosses through. So that's a whole number point. And then it's not crossing through any whole number points here, but then that's the next whole number point. That's the next integer coordinate point. And they've also told us that you go up 2 and across 3. gradient is going to be up over across, which is 2 over 3. So the equation of this line is y equals m is the gradient 2/3 x, and c is the y-intercept, which is minus 3. So that's the equation of that line there. So that's y equals 2/3 x minus 3. In this case, I can see the two intercepts. I can see that it intercepts the y-axis at minus 3. Let's do that in blue. It intercepts the y-axis at minus 3 and intercepts the x-axis at 5. And so it's going to be, the equation is going to be x over, what is the root? The root is 5, plus y over, what is the y-intercept? The y-intercept is minus 3 equals 1. Maybe we'll just tidy that up to x over 5 minus y over 3 equals 1. And then just move it on to there. Okay, so that's the equation of that line. Okay, so this is your question 3. There are 4 lines and you have to find the equation of them. And I can see that they've helped you out with this, the cyan coloured line. They've highlighted 2 points on there. And with the orange coloured line, they've highlighted 2 points on there. So making it as easy as possible for you. It says calculate the 4 angles. What does it mean by calculate the 4 angles? It means these angles here. This angle here. And this angle here, and I think we know that's a 90 degrees, and this angle here. Okay, so in that quadrilateral we want to find those 4 angles, and we're going to have to figure out how we can calculate those 4 angles. That bird has a very interesting hunting technique. You might want to look that up. Okay, and then the last bit that we've got to do is, what if we want to use an algebraic method to find an equation? We don't want to use a graph. And these are the different situations we might encounter. So let's start off with the first one. We've got a vertical line through minus a half, comma 3/4. And so vertical lines are always of the form x equals a. So it's going to be, the x coordinate is always going to stay the same. And we can see that the x coordinate here is minus half. Other points on that line will have to have the same x coordinate. So the line is just x equals minus a half, is the equation of that vertical line. Find the equation of the line with gradient 3/8 through 0, minus 3. Now I've put here given the gradient and the y-intercept. And it doesn't say that this is the y-intercept, but if you think about it, if this is your grid, and it goes through the point 0, minus 3, minus 1, minus 2, minus 3, then that would be the y-intercept. Would be, it would be like that. Gradient of 3. So this is the y-intercept. They've disguised it. They haven't told you it's the y-intercept, but they've disguised it. But it is still the y-intercept because its x-coordinate is 0. And so we're just going to fill the gradient and the y-intercept into there. Y equals, the gradient is 3/8 x, and the y-intercept is minus 3. So really straightforward to find the equation of that line. Now they've said find the equation of a line with gradient minus 1/4, and then they've given us a point that the line goes through, and a point. And so we're going to use this method here. So the equation that we're going to use, y minus y1 equals mx minus x1. Now let's go through that. M is the gradient. M is the gradient. And we already know the gradient is minus 1/4. So that's what's going to go in there. x1 and y1 are the coordinates of the point that you've got. And so this is my x1, and then this is my y1. Y minus, the y1 is minus half, watch out for the double negative, equals the gradient is minus 1/4 x minus x1 is 6. It's minus 6. Okay, now we can multiply this out, but I'm not going to. Instead, what I'm going to do is just make my life a little bit easier. First thing I'm going to do is just change that minus to a plus. You know, when you have a negative next to another negative, you can just change it to a plus. And then I'm going to multiply through by 4, multiply through by 4, multiply through by 4, and multiply through by 4. That's to cancel that out. This is all one term, so you don't have to write another multiply by 4. And so that gives me 4y, half times 4 is 2, plus 2 equals minus brackets x minus 6. So first thing I'm going to do is get rid of the fraction, get rid of the denominator of that fraction. Now I'm going to multiply this minus out. So that's going to be minus x plus 6, 4y plus 2 equals. And then what I'm going to do is I'm going to move the x over to the other side. So I'm going to add x to both sides, add x to both sides. And that's going to give me 4y plus x plus 2 equals 6. And then I'm going to shift the 2 across. So I'm going to minus the 2. And so that's going to give me 4y plus x equals 4. And I'm going to write that as x plus 4y equals 4, which is of the form ax plus by equals c, which is that standard form. So when we use this method, here, we pretty much always put it in standard form at the end of it. Whereas when we use the y equals mx plus c method, we just leave it like that. We don't write it in standard form. Wouldn't really have a fraction here, so we don't write it in standard form. Okay, and then the last question, which is given 2 points. So now we're given 2 points, What we're going to do is we're going to use these points to find the gradient. That's what this is telling us. Use the points to find the gradient. What it's telling us is, first of all, write the 2 points, P and Q, one underneath each other. It doesn't matter which one you write at the top and which one you write at the bottom. Makes no difference whatsoever. So I'm going to write Q equals 9, minus 3, and P equals minus 3, 5. Now it says subtract. Big subtract sign. And so I'm going to do minus 3 subtract 5. Minus 3 subtract 5. That's going to be minus 8. Minus 8. And then I'm going to do 9 subtract minus 3. Watch out for that. 9 subtract minus 3, which is the same as 9 plus 3, which is 12. So that's going to give me 12. And then it says reverse divide. Reverse. It's put an up next to there and a cross next to there. When you're subtracting the y coordinates, you're working out how much you have to go up. And when you're subtracting the x coordinates, you're working out how much you have to go across. Up, the suffixes up and across here if you want to. Anyway, what we're going to do is we're going to reverse divide. Reverse divide. Reverse divide is like that. Not a forward slash, but a backslash. And we're going to say that's equal to the gradient, which is minus 8 over 12, which cancels down to 2 and 3. So it's minus 2 over 3. So now I know that the gradient connecting them, the gradient connecting them is minus 2 over 3. Now I can switch back to this method here, because I now know the gradient, and then I can use, you need the gradient on 1 point. So I'm just going to cross out this point. You only need 1 point now. So I'm going to cross it. I used it already, but I'm crossing it out now because I don't need it anymore. And then I'm going to do the same thing as we did before. Y minus y1 equals mx minus x1. That's the gradient. That's the x1, and that's the y1. One goes here, and the x1 goes here. Okay, and so let's just write that out. Y minus y1 is 5, y minus 5 equals the gradient is minus 2 over 3, x minus x1 is minus 3, minus 3. There's a double negative again there, let's just change that into a plus. Okay, let's get rid of the fraction by multiplying through by 3, times 3, times 3, times 3. This is all one term. You only need times 3 once here, don't do it repeatedly. And so that gives you 3y minus 15 equals minus 2x plus 3. Let's multiply that out. Minus 2x minus 6 equals 3y minus 15. Let's take the x's and y's onto the same side. Let's add the 2x to both sides. Add the 2x to both sides. And that's going to give me 3y plus 2x minus 15 equals minus 6. Add the 15 to both sides. Add the 15 to both sides. And so that's going to give me 3y plus 2x equals 9. I'll just tidy that up a little bit. We want it in the form ax plus by equals c. So I'm going to rewrite it as 2x plus 3y equals 9. All I've done is just swap these two terms around. Nothing more complicated than that. I've just taken that one there and that one there and just swapped them around. So the 2x is here and the 3y is here. Just swap them around. And so there's my answer to that question. Again, we've given it in that standard form. We haven't given it in the form y equals mx plus c because, well, this type of question that's how you deal with it. Okay, so this is the class practice, and the grids are on the same link as you've got below for questions 1, 2 and 3 that you need to do. So the grids are on that same PDF, so make sure you print off the grid so you've got them ready in class. It's going to make it a lot quicker for you to then do these questions in class. Maybe even have a look at them beforehand and see what's going on. Okay, that's it. That's this lesson done. We're going to do more on plane geometry next lesson, and a little bit more on the equation of a line and how we can use the equation of a line. Okay, I'll see you in the next lesson primer. Mena will see you in the lesson. Bye.